Hello friends, today we are going to discuss about how to prepare carboxylic acids. So today's topic is preparation of carboxylic acid. So in previous classes we said like this, carboxylic acids means general formula RCOOH. R stands for either alkyl group, maybe R stands for aryl group. So in preparations also we discuss how to prepare alkyl carboxylic acids, how to prepare aryl carboxylic acids. So when I'm preparing alkyl carboxylic acids, it is like this. We have different methods. One is from aldehydes. Next I can prepare from alcohols. I can prepare from acyl chlorides. We call that as acyl halides. I can prepare from esters. I can prepare from cyanides. I can prepare from anhydrides. A list seems to be lengthy, but the answers are very simple. I can prepare from amides also. So I am taking the different functional group from which we can prepare carboxylic acids. Almost 7 function groups I can use, but methods are very simple, very easy ones. When it comes to preparation of aryl carboxylic acids, we can use a few of them also, but special one we use is methyl benzene. From methyl benzene, how to prepare? From methyl benzene. Yeah, these are the different preparations. Let's see each and everything. Yeah, first one is, as we know, from alcohols. How to prepare carboxylic acids from alcohols? It's very simple. Let us take one alcohol, a simple alcohol, ethanol, CH3CH2OH. Let it react with an oxidizing agent, which means alkaline KMnO4 in presence of acids with water. Acid means I will represent as H plus, water means H2O. If I add all these things, very simple. Just if you see the difference, the carbon which is attached with OH, these hydrogens from that carbon is replaced with oxygen. Means this is a chemical which is removing hydrogens, adding oxygen to the compound. That is why it is called oxidizing agent, which is supplying oxygen to others. So from alcohols I can prepare carboxylic acids just by removing hydrogens, replacing with oxygen. So simply I can call this as oxidation process. Oxidation of alcohols. In place of this alkaline KMnO4, I can use other chemical like potassium dichromate with acid like H2SO4. I can use this chemical also in place of that. This chemical also supplies oxygen to others. I think it's clear. Or I can use other chemical called Jones reagent, or I can use chemical called chromium trioxide with acid. It is called a Jones reagent. So when you're converting alcohols to carboxylic acids, I can use any of these three oxidizing agents. They oxidize others. That is why they are said to be oxidizing agents. Oxidizing agents means which oxidizes others but reduce itself. That is what oxidizing agents means. Sometimes in the same process, we can use like this. From aldehydes also I can prepare carboxylic acids. Let us take one example of aldehyde, CH3 CHO. To this we can use the same chemicals. Whatever the compounds I am using, I can use same compounds. We call that as oxidizing agents. Very simple. They just supply oxygen. Oxygen is added like this. So from alcohols or from aldehydes, the same reagents I can use to get carboxylic acids. So preparation is same. Only the reactant changes. So let's see the next one. That is from cyanides. From cyanides, how to prepare that? Cyanides means, take one example. CN is said to be cyanide groups. Methyl cyanide. These cyanides on reaction with an acid, any acid, with water. If I add acid with water, very simple. We can tell like this. Simply, and first we get amides. Next, if we continue that with the same chemical, and if we heat it, we get carboxylic acid. Now let's see. In this case, we have amides also, we have cyanides also. Both are involved in same step. Let's see how it is happening. So when cyanides are there, when you add any acid, or I can use a base also. OH minus. Let's see. Suppose when I add acid with water, this triple bond between carbon and nitrogen, these electrons are taken by nitrogen. Nitrogen gets negative charge, carbon gets positive charge. That's called electronegative characters. Water breaks as H plus and OH minus. So H plus attacks on minus, minus attacks on plus. So if we see this, on the carbon we have OH group. And now triple bond is there between them. Now it becomes double bond. Because one bond is removed, in place of that bond only one side OH is attacked. On the nitrogen, hydrogen is attacked. Again, the same acid with water is there. So water breaks as H plus and OH minus. Again, these electrons moves towards nitrogen. Nitrogen gets negative, carbon gets positive. Positive moves towards negative, negative moves towards positive. That means we get like this, CH3C. On this carbon, again OH will be there with a single bond, NH, NH, like this. But on this carbon, we have two OH groups. Remember, wherever you see on one carbon, if two OH groups are there, it won't be stable at all because two oxygen groups are electron withdrawing groups. They will be pulling electrons. They won't be stable. That is why these electrons are taken by oxygen. Oxygen gets negative. Now carbon is losing electrons to oxygen, so we try to form bond with other atom. So this oxygen pulls electrons from hydrogen. Oxygen gets negative, hydrogen gets positive. Now carbon, as lost electrons to oxygen, becomes positive. That means we have with C, with one of the oxygen, it forms double bond. And H2, and this OH minus combines with H plus and forms water. Water is removed. So in this first step, when cyanides are reacted with acids with water, we are getting amides in first step. Amides, RCONH2 means amides function group. If we continue this with the same acid and water, water breaks as H plus and OH minus. Now again these electrons are taken by nitrogen. Carbon is positive. Negative attacks on positive. Positive attacks on a negative. And we have to heat here. Why we have to heat? Let's see. We have CH3. On the carbon, OH and double bond O plus hydrogen is attacking on NH2, it becomes NH3. When you're heating, this NH3 converts to gaseous form, it goes off. That is how we get carboxylic acids. In all this process, I used either acid or base with water. So this is called hydrolysis. Lysis means breaking, hydro means water. This compound of cyanide is broken in presence of water. That is why it is called hydrolysis of cyanides. Even amides also undergoing hydrolysis only with acid and water. I think it's clear. Let's go to next preparation.